Hello students, welcome back to today's one more new video lecture here. In the previous lecture, we have already studied definition of alcohols, classification of alcohols, and then after that, in the last lecture, we have studied nomenclature of alcohols. There are different three methods used for the naming of alcohols. Common name method. There is one more method, that is trivial system. And then after that, according to common name method, first we have to write the name of alkyl group, and then we have followed that is to be followed by the word alcohol. Therefore, according to common name method, alcohols are known as alkyl alcohols. And in IUPAC method, we have to replace ending E of parent alkane by OL. Therefore, alcohols are known as alkanols. That is to be according to a UPSC system. Here now, today we are going to see here preparation of alcohols. There are different 5 methods used for the preparation of alcohols. Just we'll start the first one, that is from alkyl halide or alkaline hydrolysis of alkyl halides. Now this method from alkyl halides or alkaline hydrolysis of alkyl halides, this method already we have studied in the first chapter, that is halogen. Just there is a repetition of that method here now. Now here alkaline hydrolysis, when alkyl halide is heated with aqueous alkali like NaOH or KOH, or instead of NaOH and KOH we can take also moist silver oxide, then alcohol is obtained. See here now, just R bond X is the general formula of alkyl halide. Alkyl halide, when it is heated with aqueous NaOH, then it gives. Reaction is very simple now. This X combines with this Na, and it is a nucleophilic substitution reaction. X, it is a nucleophile X minus, that is to be replaced by the strong nucleophile, that is OH minus, and it gives ROH plus NaX. ROH is the general formula of alcohol. In this way, we can convert alkyl halides into alcohols by using alkali like NaOH. Now, instead of this NaOH, we can take here KOH also, caustic soda. NaOH means caustic soda. KOH means caustic potash. KOH. Same reaction is here now. Just this X combines with this K like this. A product that is same, ROH. Just there is a difference in the byproduct. Instead of this NaX, we will get here KX. Means the reaction is same. RX plus KOH. It should be aqueous. Aqueous means we have to prepare the solution of KOH in water. If we have taken that, if we take the KOH in alcoholic medium, then there is a elimination reaction takes place and formation of alkenes takes place. That reaction is also included in our syllabus. That reaction we will see later on. It is important. We have to write here aqueous KOH or aqueous NaOH. Now, instead of this KOH, NaOH, we can take here also moist silver oxide. Means the formula of silver oxide is Ag2O. Moist means this Ag2O absorbs the water molecule, and it is converted into Ag2O plus H2O. It is get converted into, there is a reaction between that Ag2O and H2O. Reaction takes place like this: Ag, and here is O plus HOH. Now here this OH combines with this Ag, and it gives 2AgOH, silver hydroxide. It means that there is a reaction between this Ag2 and H2, and formation of AgOH takes place, and this AgOH reacts with this alkyl halide again. This Ag combines with this X, and here this R combines with OH, ROH plus AgX. Here now byproduct is different: NaX, KX and AgX. We can take here NaOH, KOH and AgOH. That you have to remember. Alkyl halide, when alkyl halide is heated with moist silver oxide, then alcohol is obtained. In this way, we can convert alkyl halides into alcohols by using NaOH means caustic soda, KOH means caustic potash, and Ag2OH2O that reacts and use AgOH silver hydroxide. In this way we can convert alkyl halides into alcohols by using that KOH, NaOH and AgOH. Here now we can take here the examples like this. Instead of this R alkyl group, we can take any alkyl group like methyl, ethyl, N-propyl, isopropyl, N-butyl, sec-butyl, tert-butyl, N-neopentyl, N-pentyl, sec-pentyl, like that. Now suppose instead of this R we have taken here ethyl group, and instead of that X we can take here ClBrI. Ethyl bromide is treated with NaOH. It should be aqueous. Heat. It gives this Na combines with this Br and it gives CH3CH2OH plus NaBr. It is ethanol. Ethanol or ethyl alcohol. It is ethyl bromide or bromoethane. It is IUPAC name of this compound is bromoethane. When ethyl bromide is heated with aqueous NaOH or aqueous KOH or moist silver oxide, then ethyl alcohol is obtained. I have taken here only one example. That is, instead of this R, I have taken here ethyl group. You have to write more reactions by taking the different alkyl groups like methyl, ethyl, N-propyl, isopropyl, N-butyl, sec-butyl, tert-butyl, N-pentyl, neopentyl, like that. Here, and instead of this X, you can take here ClBrI plus NaOH or KOH or AgOH. I have taken here only one example. Then now, it is important for the NEET point of examination. NEET examination, it is important. There will be a question that may be asked here in the NEET examination like this. Order of reactivity alkyl halides. Order of reactivity of alkyl halides. Now, which alkyl halide easily reacts with aqueous KOH, NaOH or AgOH, and that order is like this. Tertiary alkyl halides. Tertiary alkyl halides easily reacts with aqueous KOH, NaOH, then secondary alkyl halides, and secondary alkyl halide easily reacts with then primary alkyl halides. This order that is important. It means that tert-butyl bromide easily reacts with aqueous KOH, NaOH or AgOH, then sec-butyl alcohol, and sec-butyl alcohol easily reacts with AgOH, KOH, NaOH, then N-butyl alcohols. That you have to remember here. I have given here also. Tertiary alkyl halides reacts easily with secondary alkyl halides. Secondary alkyl halides easily reacts with the primary alkyl halides. This point, it is necessary or it is important as the NEET examination is concerned. Then again, if we have studied the reactivity of halides, then iodides are more reactive than that of alkyl bromides, and alkyl bromides are more reactive than that of chlorides. If we have taken the same alkyl group, suppose we have taken here CH3, here CH3, here is again CH3, CH3I, CH3Br, CH3Cl, then which alkyl halide is more reactive? Iodides are more reactive than that of, if alkyl group is same, then iodides are more reactive than bromides, and bromides are more reactive than chlorides. You have to remember this also. Now it is regarding about the first method of preparation. First method of preparation from alkyl halides. Now we will go through to the another method, that is second method. That is, first method is from alkyl halides, second one is from alkenes by acid catalyzed hydration of alkenes. Refer. Now this method, it is not given in the 12th book. Just there is a given like this. Refer 11th chemistry section 15.24 on page number 243. This method is not given in the book of 12th. For this method you have to refer the 11th chemistry book, and that is section 15.2. It means that chapter number 15 2.4 on that is to be given on page number 243 of the 11th book. Here now, in acid catalyzed hydration means alkenes means the compounds in which carbon-carbon double bond is present. Now, we have to convert this alkene into CH2 double bond CH2 into CH3CH2OH, that is alcohol. And now for that purpose, we have to do the reaction of this ethylene with concentrated H2SO4. With concentrated H2SO4. In the first step, there is a formation of alkyl hydrogen sulfate, and that alkyl hydrogen sulfate on reaction with ion hydrolysis gives ethanol. Now, this method is like this. This method is like this. Here now, see this one now. Here is the example now. I will take here the example like this. See this one. Yes, I have taken here the example. So now this ethylene, it is ethylene. When this ethylene is heated with cold concentrated H2SO4, then ethyl hydrogen sulfate is obtained, and that ethyl hydrogen sulfate on heating with water gives ethanol. This reaction is important. Here now, ethyl hydrogen sulfate means ethylene. This is ethylene, CH2 double bond CH2. It is treated with cold concentrated H2SO4 means we can write H2SO4 like this, SO3HOH. It should be cold and concentrated H2SO4. Cold concentrated H2SO4. See this one. The bond between this oxygen and hydrogen atom breaks here, and at the same time, here is a double bond between these two carbon atoms. One of the bond breaks here, and we will get the structure like this. Hydrogen, it goes to this carbon atom, and that remaining part OSO3H, that goes to this another carbon atom, and we will get the structure like this. CH2 म्हणजे इकडचा H ह्याच्यामध्ये ॲड झाल्यानंतर CH3 झालं. Here is a single bond now, and CH2 there is OSO3H, and the name of this compound is, this is ethyl group, it is hydrogen atom, and it is SO4 group, therefore name of this compound is ethyl. This one, H means hydrogen, ethyl hydrogen, and SO4 is known as sulfate. The name of this compound is ethyl hydrogen sulfate is obtained. Now this ethyl hydrogen sulfate on heating with water gives ethanol. See this one now, CH3 CH2 OSO3H plus H2O. It gives now, see this one, the bond between this oxygen and sulfur breaks here. Water molecule, addition of water molecule takes place like this. H goes to this oxygen, and OH group is attached to this SO3HOH. It means that when there is a combination of this SO3H with OH, then there is a formation of again SO3HOH means H2SO4. H2SO4 is regenerated here, and we will get the compound like this, CH3CH2O, and it is attached to this H, and we will get the structure like this, CH3CH2OH plus H2SO4 is regenerated. CH3CH2OH means ethanol or ethyl alcohol. Here now, you see here again, ethyl hydrogen sulfate, or that is ethanol, is obtained. Same reaction I have given here also. CH2 double bond CH2 plus SO3HOH, it gives CH3CH2OH, ethyl hydrogen sulfate. This CH3CH2O SO3H plus H2O on heating with water molecule gives CH3CH2OH, and H2SO4, that is sulfuric acid, is regenerated. Now here, in this reaction I have taken here symmetrical alkene. But if we use here, if we use the unsymmetrical alkene, then we have to use Markovnikov's rule. That you have to remember here. I have taken one more example here. See this one now. When propylene, that is propylene is an example of unsymmetrical alkene. When this propylene, CH3CH double bond CH2, propylene, it is unsymmetrical alkene. जर समजा आपण डबल बॉन्ड पासून जर ब्रेक केलं, दोन्ही जर वेगवेगळे पार्ट मिळत असतील तर तो अनसिमेट्रिकल अल्किन असतो. इट इज अनसिमेट्रिकल अल्किन. When it is treated with OH SO3H, it is sulfuric acid. मी अशी खाली रिॲक्शन लिहितोय. Then it gives now. It should be cold, concentrated H2SO4. It gives here now. The bond between this oxygen and hydrogen also breaks here. See this one. It is important. Here now, this H, here see this one. CH3, CH, single bond, CH2. One of the bond of this carbon atom becomes vacant, and also one of the bond of this carbon becomes vacant, and this H now, this H, according to Markovnikov's rule now, hydrogen always goes to that carbon atom which carries the already more number of the hydrogen atoms, or which is least substituted. Therefore, H goes to this carbon atom. It means that this CH2 is get converted into CH3, and this much part OSO3H, it is attached to this carbon atom, and the name of this compound is, it is attached to the sec propyl hydrogen sulfate, or it is also known as isopropyl hydrogen sulfate is obtained. And now this compound on hydrolysis, means addition of water molecule, here is the bond between this O and H breaks here again. H goes to this oxygen and OH goes to this H2SO4. SO3H OH combines and formation of H2SO4 takes place, and we will get here the compound like this: CH3CH CH3 plus H2SO4. We will get here sec propyl alcohol or isopropyl alcohol. Many students, they do the reaction opposite to this, and there is a formation of N-propyl alcohol, but that is wrong, because we have to use here Markovnikov's. You have to remember that it is unsymmetrical alkene. Therefore, we have to apply the Markovnikov's rule. This hydrogen goes to this carbon atom. Therefore, we will get here isopropyl hydrogen sulfate, and that isopropyl hydrogen sulfate on hydrolysis gives isopropyl alcohol. Here again, if finally I have taken one more example here. Reactive alkenes directly react with water in the presence of acid to give alcohol. Addition of water takes place according to Markovnikov's rule. Sometimes if there is a more substituted alcohol is there, then that alcohol reacts with, sometimes more reactive, means more substituted alkenes are there like this. 2-methyl propene or isobutylene reacts directly with water molecule in the presence of acid and gives third butyl alcohol. Again here addition of H2O takes place. According to Markovnikov's rule, H goes to this carbon atom and OH goes to this another carbon atom, and 2-methyl propanol to all is the final product. With this we have completed the second method of preparation. Remaining part that we will discuss in the next period. Today stop here. Thank you.